Welcome to algebra class and your first video. I'm going to show you how to use some resources in this video that you're hopefully going to grow in your strength and understanding of these resources throughout the semester to help you understand algebra. So algebra is really taking math and using letters and symbols to represent unknown numbers, unknown values that we don't know. So I'm going to also throw in as much as I can terminology of past class. So like any terminology that you should probably know for this class, I'll always try to kind of re-explain it as best I can. Any questions that you have about any of the videos, please send me a message or a text in the Remind texting or an email or through Canvas. I want to help and support you as best I can. So as you're doing the notes, I suggest that you have them printed out. If you want me to print copies for you and get them to you, let me know that. There's going to be notes for every lesson this semester, and it's going to be better for your understanding if you have them printed on paper so that you're not trying to write all of this down. And then you can just write the things that I'm writing. It'll provide you with a good resource when you go to take your test, because you can use your notes on your test. That should help you, support you. Even though you're in the Lockdown browser, you should be able to have those with you. So let's just get going. It says a linear equation in one variable is any equation that can be put in the form of this. So some number times x plus b equals c, where a, b, and c are all numbers, all constants, values that don't change. That's a constant, a value that doesn't change. And a cannot be 0. And the degree is 1. So when it says the degree is 1, that means that x has an unsaid 1 as the exponent, okay? That is the degree of 1. And in the word linear, we hear also the word line. Okay, so some things to think about. So these are some examples of a linear equation in one variable. When you don't see any number next to the x, we're assuming it's an unsaid 1. So a would be 1, b would be 5, and c would be 2. This is also an example where a would be 3, b is the -4, and c is 9. This third one is also an example of a linear equation of one variable. A is 1/3, B is 8, and C is 1/2. So just helping you identify a linear equation. The main thing is that the degree is 1, where the x has an unsaid 1 as the exponent, which is a little number up to the top right. So every placement of every number in math has a purpose, and it's giving you clues to what's happening. Okay, the solution set for an equation is a set of all numbers that, when used in place of the variable, make the equation a true statement. For a linear equation in one variable, there can be only one answer. Only one answer. Okay. So 2 or more equations with the same solution set are called equivalent equations. And these 3 equations are all equivalent. 2x minus 3 equals 9. There's a number that equals x, that when you multiply it by 2, when the number is next to a variable, we're assuming there's multiplication happening. So 2 is being multiplied by x, and then when you subtract 3, you get 9. So equals means the result is. Result is the same as there's a number when you multiply it by 2 that the result is 6. these three are equivalent where X is equal to 6. So I'm going to show you how to check this in Desmos. Desmos is the online graphing calculator that we're going to be using this semester. And there's going to be times where I'm expecting you to upload your work. So for this lesson, I'm expecting you to scan in your notes from lesson 2.1. And I'm also expecting you to scan in your Desmos link. So I'm going to show my screen in Desmos. So when you get your Desmos account, which you should have already done in the Getting Started video, your name should be right here at the top right. See where my mouse is? My name is right there. And your name should be there when you log in. And this down arrow gives me some options that you're not going to really need. Now, anytime you start working, I suggest that you save. So you can't save until you start something. So I'm going to type in right here in this line, it says a little 1 there. I'm going to type in my equation. You can use your keypad to type, but down here at the bottom left, see where my mouse is now at the bottom left, it says show keypad. I can click on that, and that's also going to give me some symbols and things I can do in here. So the more that you play around in here in Desmos, the more comfortable you're going to become. We're going to use mostly things on this keypad. This function button actually brings up some other menus that we will use maybe a little bit throughout the semester, but not a whole lot in this class. Okay, so for right now, I'm just going to type 2x minus 9 equals, oops, it was 2x minus 3 equals 9. A few things. Desmos, you're going to want to use lowercase letters. And because I did an equals, it produced the graph that matches this equation right here. Notice that it looks like a straight line going up and down. 2x minus 3 equals 9. And you can see it's at x, it's at when x equals 6. So this is the quadrant system. We're going to learn more about this later in the lessons upcoming, but it's where X is a number line moving left and right. And also Y is a number line moving up and down. And so this is X over here at 6,0 is this point right here where my mouse is. I'm going to then click on the next line and I'm going to type in the 2x equals 12. And I'm going to hit return. And then I'm just going to type X equals 6. And you can see they all have 3 different colors. And when I click on them, I can turn off the graph, but you can only see one line, and that's because they're all equivalent. So when I typed all 3 of them, they actually become the same line. That's how we know in Desmos that they are equivalent equations because they create the same graph. So yep, you can click over here and turn them on and off where my mouse is right now. And because I've been typing something, I can save. So I would like you to save this as, you can type math 104 if you'd like, or you can call it just lesson 2.1. And then hit save. And then as you're working in this lesson, you're going to just keep hitting save. And then I'm going to show you how to send this to upload your work here. Okay, so let's go back to our paper. Let's look at the page. So it says, to prove that equations are equivalent, we use some truths about math, equations, and specifically equivalent equations. So one of the truths that we're going to use is called the addition-subtraction property of equality. And it says for any 3 algebraic expressions, A, B, and C, if we know A and B equal each other, then we can add C to A and we can add C to B, and they will still be equal to each other. Because we're adding the same, it says it is similar to substituting an ingredient when baking. Okay. So an example for this is 2x plus 3 and 5x minus 6. We're going to type them into Desmos. And you can see where they are equal on the graph. If you click on the gear, you can see what x makes them equivalent. Now add 7 to both expressions. Does it change the x values that makes them equivalent? So let's go to Desmos here. I'm going to turn off my graphs from before. They're still there, but they're just not turned on. And I'm going to say 2x plus 3. So 2x plus 3, it just graphed a line at 2x plus 3. And now in the new line, I'm going to type 5x minus 6. And it looks like, I'm thinking they intersect up here. It looks like they're heading for each other, but I can't really see that. Now, if you can grab your mouse and drag this graph down, you should be able to see their intersection. Okay. And I can click on the point where they intersect. So they intersect at 3, 9. So I'm going to type that. And it looks like it's typing weird. So if you go up to this plus button, does everybody see where my plus button is? It says add an item. I'm going to click on this quote where it says note, and that's going to let me type words. So I can say they intersect at parentheses 3, 9. That means when x equals 9 and y, well, x equals 3 and y equals 9. Okay. It says now add 7 to both expressions. So I'm going to take that expression, 2x plus 3. Whoops. You can always hit the back arrow if you do something you don't want to do. So I'm going to copy that. And I'm going to put it down here. So, and I'm going to type 5x minus 6. So I'm just going to retype them. But now I'm going to add 7. It says on step 3, it says now add 7. So I'm going to add 7. Okay. And I'm going to add 7. Okay. Now it looks like I have 2 different lines. Remember the first 2 lines right here, they intersected at 3, 9. I'm going to turn off their graph for just a minute, and I'm going to grab my graph and I'm going to go up and I'm going to see where these 2 new lines where I added 7, where did they intersect? And it looks like they now intersect at 316. The key is that x equals 3 is still the same solution that makes them both true. Okay, so I added 7 to both, and x equals 3 is still the same solution. Go ahead and hit save so that all of this is on your Desmos graph. Remember, if you make a mistake, you can hit this back arrow and it will go back as many times as you need it to. So let's go back to our paper. Another truth that we're going to look at today is the multiplication or division property of equality. So for any 3 algebraic expressions, A, B, and C, where C cannot equal 0, if we know that A and B equal each other, we can multiply A by C, and it will still equal if we multiply B with C. Again, this is similar to baking, where we multiply and do multiple batches of baking. We can multiply the amount of the ingredients as long as we multiply each ingredient by the same amount. So if we go back to our equation, 2x plus 3 and 5x minus 6 on a graph, now it says if you click on the gear, you can see what X makes them equivalent. So we're gonna go and look at that. And then it says, now put parentheses around both expressions and multiply each expression by 4. Does it change the X values that make them equivalent? Remember that X equal to 3 is what made them equivalent. So let's go ahead and multiply them by 4. So I am going to just copy and put them down here again so that we can start fresh. And I'm going to turn off these other graphs. Okay, so I can see when I talk about the gear, I'm talking about this right up here. Do you see where my mouse is? It says edit list. You can do that, and you can create a table with them. So it will let you know the X values and the Y values. If I put X into 2X plus 3, this is what the Y values that come out. And I can click on 5X minus 6 and I can hit the gear and I can do the same thing. And you can see that they don't have any that match, but I'm going to go up to the 2X plus 3 and I'm going to hit enter and I'm going to put 3 as my X and I get 9. And then I'm going to go down to 5X minus 6 and hit enter and I'm going to put 3 as X and I also get 9. That's what shows that 3 is a true solution, because putting 3 into both of my expressions, I get 9. Now I wanted you to put parentheses around them both. And then I'm going to put 4 there. That's going to multiply by 4. And I'm going to do the same here. Now I'm going to exit out of the table because this table was not for my change. It was just for the original. Okay. Now I'm going to go up and see where they intersect. I'm zooming in with my mouse here. But you can see that they still intersect at X equals 3. So I'm going to make a note using my plus symbol here. I'm going to say they still intersect at X equals 3. So those are our two truths that we're using, the addition property and the multiplication property. So if you flip the page, I give you some instructions here on how to solve linear equations in one variable. And you can see that these boxes are going to be familiar because they're from your book. I just put them into the notes so that they're a quick resource. So the first step that you're going to use when solving an equation in one variable is use the distributive property to separate terms if necessary. Okay, so there's probably some words that are like, oh no, what are these? Distributive property. The distributive property, I think of that as like you're handing out a newspaper, somebody's walking around class and they're handing out a paper where everybody gets the same paper. You're distributing the paper. And terms. Terms are letters, values that are being added. Are expressions that are separated by addition or subtraction. Okay. So 2x plus 3, 2x is a term and 3 is a term because they're being separated by addition. 4x minus y, 4x is a term and y is a term because they're being separated by a subtraction. These are separated by an addition. Okay. I'm going to go through examples of using this. 1b says, if fractions are present, consider multiplying both sides by the least common denominator, that's LCD, to eliminate the fractions. If decimals are present, consider multiplying both sides by a power of 10 to clear the equation of decimals. Combine similar terms on each side of the equation. Then step 2 says, use the addition property of equality to get all variable terms on one side of the equation and all constant terms on the other side. A variable term is a term that contains the variable. A constant term is a term that does not contain the variable. Step 3, use the multiplication property of equality to get the variable by itself on one side of the equation. Step 4, this is probably the most important. Check your solution in the original equation to be sure that you have not made a mistake in the solution process. We can check our work to make sure that we are correct. Okay. So catch me back for another video where I'm going to solve these equations.